Hello, welcome to this video. This is 4-1 Essentials of Calculus. This is the second video. In this video, we're going to talk about the mean value theorem, the MVT, and we're going to apply it to some problems, okay? So before we do that, I want to go ahead, I want to look at some cases where you can kind of construct the mean value theorem and help you remember it. So for these examples, 10 through 15, they ask us to draw the secant line between 2 points, A and F of A, and B of F of B. So I'll draw the secant line. Remember, a secant line is just connecting these points, and I'll try my best. If you have a straight edge like a ruler or an ID card, that can really help you out. So there's my secant line, and then they say draw all tangent lines parallel. So a tangent line, remember, is a derivative, and the slope of the tangent line is the derivative. And if I draw it through this point right here, okay, that line's about parallel. And then I'm going to do the same thing for these 2 points. Okay, there. And, okay, so there's my tangent line. And then we have one that's kind of parallel, say, about here. Maybe one here. Okay. Oh, that's really ugly. Do better than that. I'm trying to use an ID card here. That's not really working. Let's try this. Okay. All right. And then notice here for example 12, I can connect these points like so. And notice where it would be parallel is right here. However, that point is non-differentiable, right? So here there's no tangent line. Okay, for 13, I have a function that looks something like this. Okay, notice this is not really a secant line. Not really a secant line. And then there's no points that are tangent. For 14, I can't draw a secant line because remember FA and F of A, that's on a vertical asymptote, so I don't have a point, okay? And then for 15, there's A and B, but notice where the point would be tangent, where we would have a tangent line that's parallel, I have a hole there, okay? So again, there is no tangent line. Okay, so I hope you picked up on some ideas there. Here is page or examples 16 and 17, and here we're going to do the same idea. They tell us to draw the secant line between the 2 points, 2 and F of 2 and 5 and F of 5. So here is my tangent line. Sorry, my secant line. And then I want a tangent line. So that's kind of here. All right, and that's at C is approximately 3. I'll do it again for these 2 examples. Okay, so I got one there. And I have a tangent line here and here. Get that close. Okay. And they want us to estimate the C values again. So here, that's approximately, let's say, 2.7. And then here, 4.3. Okay, notice I do have another possible tangent line here. However, that's outside of our interval 2 to 5. So I don't want to draw that one. Okay. And then we have, last but not least, 18. So if I connect these, okay, I have a tangent line here, tangent line here, and a tangent line here, okay? And those C values approximately 2.5, okay, 3.5, and what do you say, 4.5? Okay, and 4.5, right? So those values have to be in the interval. All right, so hopefully drawing those lines can help you construct what we're going to talk about. Today's topic is the mean value theorem. And here is the mean value theorem. And I'm going to kind of highlight this into some different parts here. So it says if A is continuous on the closed interval A and B, that should sound familiar, and differentiable on A to B, so and it's differentiable on this interval, then there is a number C in A to B such that, okay, and we have our mean value theorem, that f prime of C, the slope at a specific point, is equal to the average slope. Okay, so informally, the mean value theorem states that given the right conditions of continuity and differentiability, there will be at least one tangent line parallel to the secant line. And in other words, that is that the instantaneous rate of change will be equal to the average rate of change at least once. Okay, so here's an example. Given f of x equals 3 minus 6 over x, find all C which satisfy the mean value theorem on 3 to 6. Okay, so what we have to do, we have to satisfy a couple of conditions. The first condition, is it continuous on the slope, or on the interval 3 to 6. Okay, so step 1, is it continuous on 3 to 6? Okay, and here, the only discontinuity point that we can't have, x cannot be 0 for f of x. Okay, so for f of x, x cannot be equal to 0. Okay, so step 1, it is continuous on A to B. Okay, step 2, is it differentiable? Okay, on A to B. So can we take a derivative here? And remember, you can take a derivative anywhere where you don't have discontinuity, and if the derivative, okay, is not undefined. So what you have to do for step 2, we're going to go ahead, we're going to take f prime of x, okay, and f prime of x is equal to I want to rewrite this. So if f of x is equal to 3 minus 6x to the negative first, it is equal to 6x to the negative second, okay, which is 6 over x squared. Okay, so I know that it's not continuous at 0, and then there's also a non-differentiability point at our derivative at x equals 0, right? Our denominator cannot be 0, okay? So for f prime of x, x cannot be 0. Okay, so condition 2 is satisfied. All right, now part 3. Okay, so now that I've satisfied my conditions, they want to know the mean value theorem, the NVT, is guaranteeing a C on the interval A to B such that these two things are true. Okay, so here's the mean value theorem, that f prime of C, okay, so f prime of C is equal to f of B minus f of A over B minus A. Okay, so what we want to do is we want to go ahead and find this out. Okay, so we're gonna plug in values. Okay, so our interval is 6. So f of 6 minus f of 3 over 6 minus 3. Okay, and we plug these in, and what we get is, if I plug in f of 6, that's 3 minus 1. Okay, so that is 2 minus f of 3. So if I plug in 3, that's 6 divided by 3, that's 2. So 3 minus 2 is 1. Okay, over 6 minus 3. So this is equal to 1/3. Okay, and so what this is telling us is that there exists a C value such that f prime of C is equal to 1/3. Okay, well, what is my f prime? Well, my f prime is 6 over x squared is equal to 1/3. Okay, so I want to go ahead and solve this. So we can cross multiply, and we get 18 is equal to x squared. Take the square root, and you get x is equal to plus or minus the square root of 18. Well, first of all, we have to ask, okay, which of these is on our interval? Okay, and 18, this is approximately 3 root 2, plus or minus 3 root 2, and our interval is 3 to 6. Okay, so I'm not going to include the negative value. We'll throw out the negative value, and so therefore c is equal to 3 root 2. All right, and there is the mean value theorem. All right. Again, in this video, we talked about the mean value theorem, the different conditions that are satisfied, and we went ahead and looked at a problem, and we found a c value using the mean value theorem. All right, catch you next time. Peace.